Hello dear students. Theme of our lecture today is blood system physiology. Blood is a type of liquid connective tissue and together with the lymph and tissue fluid forms the internal environment of organism. Internal environment is water-based in which the cells of the body exist. Blood fulfills many vital functions and it carries out the transport function, and this function determines other functions. Respiratory function, if oxygen and carbon dioxide are transported. Trophic nutritive, when the nutrients materials are delivered to the tissues. Excretory, when the metabolites are delivered from tissues to excretory organs. Regulatory, if the hormones and biologically active substances are transported. Homeostatic, by maintenance of water content and acid-base balance. Blood participates in maintenance of body temperature as a result of distribution of blood volume between skin and the internal organs at high and low temperature of external environment. It fulfills protective or defensive function by providing of immunity and non-specific resistance by participation in blood coagulation, in phagocytosis. Blood circulates constantly around the body, enables communication between tissues. By teaching of lung about blood as a system consists of peripheral and circulating blood, organs for hematopoiesis and destruction of blood, nervous and humoral regulatory apparatus. The total volume of blood makes up about 6 to 8% of body's weight. Accordingly, a 70 kilogram person will have 5 to 6 liters of blood. Circulating blood volume will be lesser than total blood volume because some amount of blood will be deposited in organs depot: liver, spleen, lungs, skin. Blood is composed of plasma, in which different types of cells are suspended. Blood plasma is the pale yellow liquid component. It makes up about 55% of body's total blood volume. It consists of 90-92% of water, 8 to 10% of dry substance, mainly consisting of proteins, 6-8%. Dry substance includes inorganic and organic components. The main mineral components are cations, sodium, potassium, calcium, magnesium, and anions, chlorides, phosphates, bicarbonates. The organic mineral components of plasma include proteins, lipids, and carbohydrates. The hematocrit, also known as packed cell volume or erythrocyte volume fraction, is the volume percentage of red blood cells in the blood. It is normally about 40 to 48% for men and 36 to 42% for women. If a portion of blood is centrifuged or allowed to stand for a sufficient long time, it will be found that the blood cells will settle towards the bottom of the test tube while the plasma remains on top. By this means, the percentage of blood cells in whole blood can be determined. Blood plasma proteins include albumins, globulins, fibrinogen, and when a fibrinogen is removed from plasma as a result of coagulation, such plasma without fibrinogen is called serum. Blood plasma proteins fulfill transportation of hormones, creation of oncotic pressure, defense function. Proteins participate in blood clotting, in production of blood viscosity, in regulation of pH of blood. Proteins produce up to 15% of the buffering power of blood. The major plasma carbohydrate is glucose. Normally, it is 4.4 to 6.6 millimole per liter. The lipid substances are neutral fats, phospholipids, and cholesterol. Microelements are zinc, copper, manganese, cobalt. Plasma normally contains varying amounts of hormones, enzymes, pigments, and vitamins. And composition of plasma varies with the body's activity and different physiological state. Hematopoiesis. Hematopoiesis is the formation of blood cellular components. All cellular blood components are derived from pluripotent hematopoietic stem cells, which is present in the bone marrow. In a healthy adult person, approximately 10 to the 11th, 12th degree new blood cells are produced daily in order to maintain steady state levels in the peripheral circulation. Humoral regulation of hematopoiesis is provided by hormones produced by kidney and liver, erythropoietins, leukopoietins, thrombopoietins. Living organism must maintain a constant internal environment by living in a constantly changing external environment, because the processes that keep the cell alive can only take place under certain conditions. Such parameters of blood are blood pH, blood osmotic pressure, oncotic pressure, viscosity, specific gravity, erythrocyte sedimentation rate, number of blood cells, ratio between blood cells and blood plasma, and the volume of circulating blood. Osmotic pressure is the force which provides passage of water through the membrane, and osmosis is movement of water from an area of lower to the area of higher concentration of solid across a semi-permeable membrane. Osmotic pressure is maintained by dissolved particles, and normally it is 7.6 to 8.1 atmosphere. A solution with the same osmotic pressure that of blood is named isotonic solution. It is 0.9% of sodium chloride and for example 5% of glucose. If osmotic pressure is higher than that of blood, such solution is called hypertonic. If it is lower than that of blood, it is hypotonic solution. All solutions which are injected in the veins must be isotonic. If hypertonic solution is injected, water will pass out of red blood cells and we will observe shrinking of erythrocytes. And in hypotonic solution, water will pass inside of red blood cells and we will observe swelling of red blood cells. One part of osmotic pressure which is created by blood plasma proteins is called oncotic pressure. It is usually tends to pull water into the circulatory system. It is the opposing force to hydrostatic pressure, and its normal value is 0.03 to 0.04 atmosphere or 25 to 30 millimeter of mercury. Other stable parameter of blood is the pH of blood. pH is a measure of the acidity or basicity of an aqueous solution. It is the negative decimal logarithm of hydrogen concentration, and normal value of arterial blood is 7.4 and of venous blood is 7.35. If pH is less than 7.3, it is acidosis, and if pH is more than 7.5, it is alkalosis. pH of blood is maintained by excretion of carbon dioxide by the lungs, excretion of hydrogen and hydroxyl anions by the kidney, by the action of buffer systems of blood. Blood contains 4 buffer systems: carbonate, phosphate, protein, and hemoglobin. Protein buffer system has amphoteric property. It can neutralize acids and alkali. Carbonate, phosphate, hemoglobin buffer systems consist of 2 parts. One part can neutralize acids, other alkali. Blood viscosity can be described as the thickness and stickiness of blood. It is a measure of the resistance of blood to flow. If viscosity of water is taken as 1, the viscosity of blood is 5 times more than that of water. Viscosity of blood depends on number of red blood cells, on amount of blood plasma proteins. Specific gravity or relative density is the ratio of the density of a substance to the density of a given reference substance. And blood normally has a specific gravity of 1.05 to 1.06 gram per liter. The higher the concentration of red blood cells and blood plasma proteins, higher will be the specific gravity. Specific gravity has a diagnostic significance, informing about functional state of excretory organs. Erythrocytes or red blood cells are most abundant type of blood cells. Normal range in male is 4 to 5 millions per 1 cubic millimeter of blood in male, and in female 3.5 to 4.5 millions per 1 cubic millimeter of blood. In humans, mature red blood cells are oval by concave discs and they are flexible. They lack a cell nucleus and most organelles in order to accommodate maximum space for hemoglobin. Since red blood cells have an elastic membrane, they are able to change their shape when they pass through the capillaries. Due to localization of hemoglobin inside of red blood cells, they fulfill respiratory function, carries oxygen and carbon dioxide, and participate in maintenance of acid-base balance. Due to localization of agglutinogens on the surface of red blood cells, they participate in the determination of blood groups. The process of synthesis of red blood cells, erythrocytes, is called erythropoiesis. It is stimulated by decreased oxygen in blood circulation, which is detected by kidneys, which then secrete the erythropoietin. Through this process, erythrocytes are continuously produced in the red bone marrow of large bones. For maturation of erythrocytes, an intrinsic factor of Castle, which is produced by mucous membrane of stomach, vitamin B12, folic acid are necessary. At the end of their lifespan, 100 to 120 days, they become senescent and are removed from circulation by the macrophage, by phagocytic, reticular endothelial system. Main sites of red blood cells breakdown are spleen, bone marrow, and liver. When red blood cells break down, iron released and reused by the bone marrow to form new hemoglobin. Biliverdin is formed from the heme part of the hemoglobin. It is reduced to a yellow-colored pigment called bilirubin and is transported to the liver. From there, it is excreted as a constituent of bile. Increasing of number of red blood cells is called erythrocytosis, and decreasing is called erythropenia. Erythrocytosis and erythropenia can have absolute and relative characters. Absolute change of number of red blood cells means change of total number of red blood cells in organism, and relative change means change of number of red blood cells in the volume unit of blood. Absolute erythrocytosis, it is a result of hypoxia, for example, at being at high altitude, at heart and lungs diseases accompanied by hypoxia. Relative erythrocytosis, it is a result of dehydration of organism as a result of drinking low water, losing of water as a result of vomiting, excessive sweating, diarrhea. Absolute erythropenia is a result of deficiency of production, bone marrow disorder, excessive destruction of red blood cells. Relative erythropenia, it is a result of increase of fluid in the organism, injection of blood substituting solutions. Destruction of membrane of red blood cells with escape of hemoglobin into the plasma is called hemolysis. And there are different types of hemolysis: mechanical, chemical, thermal, biological, osmotic. Mechanical hemolysis is observed if bottle with blood is powerfully shaken. Chemical, under influence of different chemical substance, alcohol, chloroform. Thermal, when blood is freezed and defreezed. Biological, a transfusion of the wrong blood type, or snake bite, under influence of immune globulins. Osmotic hemolysis happens in hypotonic solution. Osmotic resistance of red blood cells is measured by the concentration of sodium chloride at which complete hemolysis occurs, and a normal value of osmotic resistance of red blood cells is between 0.34 to 0.4% of sodium chloride. Hemoglobin is a large molecule containing globin protein and iron containing pigment complex known as heme. The hemoglobin molecule contains 4 globin chains and 4 heme units, each containing 1 atom of iron. A single hemoglobin molecule can transport 4 molecules of oxygen. Normal range of hemoglobin in men is 130 to 160 grams per liter. In women is 120 to 140 grams per liter. Standard or ideal content of hemoglobin is 166.7 grams per liter. Types of hemoglobin. There are fetal hemoglobin, primitive, adult hemoglobin, and myoglobin, hemoglobin of muscles. Fetal hemoglobin and myoglobin have high affinity to oxygen. Myoglobin can bind 14% of oxygen, and it is important at muscle contraction. There are physiological and pathological combinations of hemoglobin. Physiological combinations of hemoglobin are oxyhemoglobin. Oxygen combines weakly with hemoglobin molecule. Such association is called oxyhemoglobin, and it is formed in lungs. Deoxyhemoglobin, then the oxygen is released to the tissues of the body. The hemoglobin is called reduced hemoglobin or deoxyhemoglobin. carb hemoglobin. In tissues, hemoglobin combines with carbon dioxide and form this combination, carb hemoglobin. The affinity for carbon dioxide is 20 times more than for oxygen. Pathological combinations of hemoglobin are carboxyhemoglobin and methemoglobin. Carboxyhemoglobin is combination of hemoglobin and carbon monoxide. It is a gas without smell and color that easily associates with hemoglobin, and affinity for monoxide is 200 times is higher than for oxygen. Methemoglobin is such hemoglobin in which iron has valence not 2 as usually, but 3, and such iron not able to give oxygen to tissue. Other stable parameter of blood is erythrocyte sedimentation rate. The erythrocyte sedimentation rate is the rate at which red blood cells sediment in a period of 1 hour. Normal values in men 2 to 10 millimeter per hour, in women 2 to 15 millimeter per hour. At pregnancy 40 to 50 millimeter per hour. Plasma proteins, mainly fibrinogen and globulin, increases erythrocyte sedimentation rate, but albumins decrease. Other factors influencing the erythrocyte sedimentation rate are number of erythrocytes, size of erythrocytes. Erythrocyte sedimentation rate increases at inflammation, cancer. Decreased erythrocyte sedimentation rate may be due to erythrocytosis, sickle cell anemia, and other pathology. The average content of hemoglobin in one erythrocyte is called color index of blood. Color index shows degree of saturation of erythrocytes with hemoglobin. It fluctuates between 0.7 to 1.1. If it is less than 0.7, such state is called hypochromia. If it is more than 1.1, it is called hyperchromia. Leukocytes. Leukocytes, normal count of leukocytes or white blood cells is 4 to 9 thousandths per 1 cubic millimeter of blood. The major function of leukocytes is protective function. It provides immunity and thus defends the body. Leukopoiesis or production of leukocytes also derived from pluripotent hematopoietic stem cells. Differentiation of lymphocytes occurs in the lymph tissue. Leukopoietins produced by liver and kidney hormones of thymus provide humoral regulation of leukopoiesis. Increased amount of leukocytes is called leukocytosis. Decreased is called leukopenia. Leukopenia is only pathological. Leukocytosis may be physiological and pathological. Pathological or reactive or through leukocytosis. It occurs at inflammation, at cancer, in the physiological is observed at food intake, physical exercises, emotions, stress, pain. Percentage of different types of leukocytes is called leukogram or leukocyte formula. A blood leukocyte formula provides information on total leukocyte count, differential leukocyte count, and leukocyte morphology. There are two main types of leukocytes, granulocytes and agranulocytes. Granulocytes are formed by a process known as granulopoiesis. They follow a common line of development through myeloblast to myelocyte before differentiating into three types. Contain multi-lobe nuclei in the cytoplasm. Names neutrophils, eosinophils, and basophils represent the dyes by which they are stained. Eosinophils takes up the red acid dye, eosine. Basophils are stained by alkaline methylene blue. Neutrophils take up both dyes and are purple. Agranulocytes, monocytes, and lymphocytes. Agranulocytes contain a large nucleus and no cytoplasmic granules. Neutrophils, they are small, fast, and active scavenger cells, provide protection against bacterial invasion. They also remove dead cells and debris from injured tissue. Neutrophils engulf and kill bacteria by phagocytosis, attract in large numbers to areas of infection by chemicals called chemotoxins, which are released by injured cells. Neutrophils are highly mobile and squeeze through capillary walls through diapedesis. Neutrophils contain lysosomes with enzymes to break down engulfed materials. Phagocytosis, it is cellular ingestion of bacteria with enzymes, proteases. Peroxidases. Neutrophilia means increase of number of neutrophils is observed at inflammation. Eosinophils eliminate parasites such as worms, which are too big to be phagocytosed, contain certain toxic chemicals which are stored in granules and released when eosinophils bind to parasitic organisms. Local accumulation of eosinophils is observed at allergic inflammation. Eosinophils promote tissue inflammation by releasing toxic chemicals. but they also reduce inflammation by releasing histaminase, an enzyme which breaks down histamine, and increasing cough, eosinophils is observed at allergy, parasitic infections, decreasing at stress. Basophils contain cytoplasmic granules containing heparin, anticoagulant, histamine, anti-inflammatory agent, and other chemicals which promote inflammation. Basophils are closely associated with allergic reactions. Allergens cause basophils to release the contents of the granules. Mast cells are very similar to basophils, but they are found in tissues and not in the circulatory system. They release their granule contents within seconds of binding with these allergens, leading to rapid onset of allergic symptoms. Monocytes are central link of mononuclear phagocytic system. They differentiate into macrophages, which can phagocytose up to 100 bacteria. They are largest of white blood cells. Some monocytes circulate in the blood and are actively motile and phagocytic, while others migrate into tissues where they develop into macrophages. Both these types of cells produce interleukin-1, which increases body temperature during infection by acting on the hypothalamus, stimulate the production of certain globulins in the liver, and enhance the production of activated T lymphocytes. Monocyte macrophage system, also known as reticular endothelial system, lymphocytes. Lymphocytes smaller than monocytes and have large nuclei. Some lymphocytes circulate in the blood, but most are present in the tissues, including lymphatic tissue such as lymph nodes and spleen. Lymphocytes provide immunity, and also lymphocytes originate from a single type of stem cell. During the final stage of development, they form into two distinct types of lymphocytes, T lymphocytes and B lymphocytes. B lymphocytes provide humoral immunity, T lymphocytes provide cell-mediated immunity. B cell lymphocytes differentiate into plasma cells, which further produces 5 classes of antibodies that provide immunity. T lymphocytes aim to eliminate virus-infected cells, cancer cells, and also causes graft rejection. Lymphocytosis is observed at cancer. Blood groups. There are different blood group systems, such as Diego, Lutgens, Duffy. That two most important blood group systems are ABO blood group system and RH, rhesus blood group system. About 55% of population has either A-type antigens, this is blood group A, B-type antigens, blood group B, or both antigens, blood group AB, on their red blood cell surface. The remaining have neither A nor B type antigens. It is blood group O. Corresponding antibodies are called anti-A and anti-B. Individuals with blood group A cannot make anti-A, however, they can make anti-B. And individuals with blood group B cannot make anti-B, they can make only anti-A. Individuals with blood group AB make neither anti-A nor anti-B. On the other hand, individuals with blood group O make both anti-A and anti-B. Agglutinogens and antigens exist on the surface of every red blood cell. Agglutinins, antibodies, are in the plasma. The clumping of red blood cells due to binding of antibody with the corresponding antigen is called hemagglutination. For example, anti-A binds A antigen, alpha agglutinin, and anti-B binds B antigen, beta agglutinin. Agglutination reaction helps in determining the blood type of a person. Determination of blood group is provided by serum. As you remember, serum is defibrinated blood plasma. 3 types of serum are used. Serum of first O blood group, of second A blood group, and of third B blood group. And drop of exempt blood is added. And this slide shows results of determination. For example, first line, we can observe agglutination in the drop with anti-A serum. It means that there is A agglutinogen in the exempt blood. A agglutinogen is a characteristic of second blood group, A blood group, and so on. Rhesus factor. 85% of the population is rhesus positive. If rhesus agglutinogen is present in blood, such blood is called rhesus positive. If not, such blood is called rhesus negative. Rhesus factor of blood is determined by anti-rhesus serum. And Rhesus is important in blood transfusion and in pregnancy. Rhesus negative person cannot receive blood from rhesus positive person. Whereas rhesus positive person can receive blood from rhesus negative person without any problems, without rhesus conflict. If a rhesus negative person receives blood from rhesus positive person for the first time, due to this exposure, there will be formation antibodies. So if a second transfusion is done, again with rhesus positive blood, then the antibodies which are already present causes agglutination and further hemolysis of red blood cells. In pregnancy, rhesus incompatibility is a pregnancy complication that can occur when a baby has rhesus positive blood and the mother has rhesus negative blood. Although there is a placental barrier that separates maternal and fetal blood, blood from the baby can still sometimes cross into the mother's bloodstream. There is especially likely to occur during delivery. Then crossover happens, the woman's immune system will react to the baby's blood as a foreign substance and produce antibodies that fight against it. During a woman's first pregnancy with rhesus incompatibility, this is unlikely to cause a problem. Usually the baby is born before there are enough antibodies to cause real harm. Once the antibodies are produced, however, they remain in the mother's body long after baby is born. If she has a second pregnancy with a rhesus positive fetus, the incompatibility may be dangerous. A first baby may also be at risk if the mother has previously been exposed to rhesus positive blood by other means, by previous birth with a rhesus positive baby, at injection with a needle contaminated with rhesus positive blood, at blood transfusion or stem cell transplant with an rhesus positive donor. Women who are rhesus negative can be treated with rhesus immune globulin to prevent them from making rhesus antibodies that could affect a current or future pregnancy. This slide shows a scheme of blood transfusion, and by this scheme we can observe that first blood group can give, donate blood to all other, but fourth blood group can accept blood from anyone, and that's why first blood group is called universal donor, and fourth is called universal recipient. But we can use this scheme of blood transfusion at once, and at transfusion of small amount of blood 200 or 300 milliliters. If we need in transfusion of large amount of blood or repeatedly transfusion of blood, we must check for ABO blood group compatibility, for resource compatibility, and also we must use cross-matching or serological or individual test by taking blood from donor and serum from recipient and vice versa. Agglutination must be absent. And biological test 3 times, introducing donor's blood in the recipient, small portions, 10, 15, 25 milliliters of donor's blood, and check for any complaints such as headache, backache, paleness of skin, and check for change of physiological parameters such as change of breathing, decreasing of blood pressure. One of blood cells is thrombocytes or platelets. They are not complete cells. Normal range of thrombocytes is between 180 to 320 per 1,000 per 1 cubic millimeter of blood. Thrombocytes circulate in blood 8 to 12 days. The main function of platelets is the maintenance, the hemostasis. Thrombocytes fulfill trophic function, transport of biologically active substances, provide immunity by phagocytosis, participate in inflammation. It is a coagulant. It participates in clot retraction. They are very small discs. They don't contain nucleus. Cytoplasm contains granules filled with chemicals that promote clotting. Platelets are produced in bone marrow by budding off from megakaryocytes, and thrombopoiesis is regulated by thrombopoietin, a hormone usually produced by liver and kidneys. Each megakaryocyte produces between 5,000 to 10,000 platelets. Reserve platelets are stored in the spleen and are released when needed by sympathetically induced splenic contraction. All platelets are destroyed by phagocytosis in the spleen and by Kupffer cells in the liver. Hemostasis. Hemostasis is a process which causes bleeding to stop, meaning to keep blood within a damaged blood vessel. It is the first stage of wound healing. Most of the time this includes blood changing from a liquid to a solid state. The opposite of hemostasis is hemorrhage. Hemostasis has three major steps: vasoconstriction, temporary blockage of a break by platelet plaque, blood coagulation or formation of a clot that seals the hole until tissues are repaired. There are two types of hemostasis: vascular thrombocytes hemostasis and coagulation hemostasis. Vascular thrombocytes hemostasis also is called microcirculatory hemostasis because it provides stoppage of blood loss from small vessels having low blood pressure, and finally platelet plug is formed. Stoppage of blood loss from the large vessels having high blood pressure is realized by coagulation hemostasis, and finally blood clot is formed. There are many blood plasma clotting factors. Many of them are produced in liver. From this slide, remember please that 2nd, 7th, 9th and 10th factors are produced with participation of vitamin K. They are K-dependent factors. Also, about 4th plasma factor, calcium ions. Calcium ions participate in all stages of blood coagulation. 12th plasma factor is called Hagemann factor or contact factor because it is activated at contact with damaged vessels wall. A deficit of anti-hemophilic ACE factor, hemophilia develops. So, vascular thrombocytes hemostasis stage of this hemostasis include vasoconstriction, adhesion, reversible aggregation, irreversible aggregation, and retraction. Vasoconstriction results from the local myogenic contraction of the blood vessels initiated by direct damage to the vascular wall. Release of local factors from the traumatized tissues and blood platelets, and nervous reflexes initiated by pain nerve impulses or other sensory impulses that originate from the traumatized vessel or nearby tissues. Release of a vasoconstrictor substance, thromboxane, serotonin by the platelets, which for the smaller vessels are responsible for much of the vasoconstriction. When platelets come in contact with the damaged vascular surface, especially with collagen fibers in the vascular wall, the platelets themselves immediately begin to swell. Their contractile proteins contract forcefully and cause the release of granules that contain multiple active factors. They become sticky so that they adhere to collagen in the tissues and to a protein called a Willebrand factor. They secrete large quantities of ADP. The ADP and thromboxane A2 provides adherent thrombocytes to the wall of the vessels, and thus forming a platelet plaque. So, in first stage, which is called vasoconstriction, constriction of vessels occurs reflexly and under the influence of serotonin, thromboxane A2, epinephrine, and Willebrand factor. In second stage, adhesion of thrombocytes. Thrombocytes stick to the internal surface of damaged vessel because internal surface of damaged vessel becomes positive charged, and but thrombocytes have negative charge. In third stage, which is called reversible aggregation of thrombocytes, other thrombocytes agglutinate to adhered thrombocytes and aggregate, which consists of platelets, is formed. In irreversible aggregation stage, thrombocytes lose their shape under influence of thrombin, and we can observe permanent platelet plaque, more stable, and at retraction under influence of serotonin, calcium ions, contraction of platelet plaque occurs. On this slide, you can observe damaged endothelium and adhering of platelet on the damaged blood vessel, releasing of ADP, serotonin, thromboxane, A2, formation of platelet plaque. Coagulative hemostasis. Platelet plaque is not resistant to high pressure in large vessels. And in large vessels, coagulative hemostasis occurs. There are three stages of coagulative hemostasis. We need in fibrin thromb. Fibrin thromb is formed from fibrinogen. Fibrinogen is produced by liver. For conversion of fibrinogen into fibrin, we need in thrombin. There is no thrombin in the blood. we have prothrombin, which is produced by liver. For conversion of prothrombin, for its activation, we need in prothrombinase, and formation of prothrombinase occurs in first stage of coagulative hemostasis. First stage coagulative hemostasis includes extrinsic pathway and intrinsic pathway. Intrinsic pathway, it is slower, takes about 3-6 minutes. It is activated when blood comes into contact with damaged blood vessels lining. It is endothelium. Blood trauma causes activation of Hemoglobin factor and release of platelet phospholipids containing platelet factor 3. Activated Hemoglobin factor activates factor 11, which needs a kininogen and is accelerated by prekallikrein. Factor 11 activates factor 9. Factor 9, factor 8, platelet phospholipids, and factor 3 activates factor 10. Factor 10 and factor 5 or tissue phospholipid form the complex called prothrombin activator. The prothrombin activator in turn initiates within seconds the cleavage of prothrombin to form thrombin. Extrinsic pathway activated rapidly within seconds after tissue damage. Damaged tissue releases thromboplastin or tissue factor, which causes coagulation. Release of tissue factor happens. Traumatized tissue releases a complex of several factors called tissue factor or tissue thromboplastin. Activation of factor 10, and factor 10 forms prothrombin activator, combines with tissue or platelet phospholipids and with factor 5 to form the complex prothrombin activator. And the final pathway is under the influence of prothrombin activator. Prothrombin is converted into thrombin, and thrombin provides conversion of fibrinogen into fibrin and fibrin monomer, and under influence of 13 fibrin stabilizing factor, fibrin polymer is formed. After that, fibrin clot retracts under influence of serotonin, calcium ions. After formation of fibrin thromb, we need in reopening the affected blood vessels, and fibrinolysis provides such reopening blood vessels and prevents development of infection. For Dissolving of fibrin thromb we need in plasmin, but plasmin is in inactive form as plasminogen. For activation of plasminogen, we need an activator, but there is no activator, we have pro-activator, inactive enzyme. This inactive enzyme is activated under influence of factor 12, kallikrein kinase system, alkaline phosphatase, urokinase, and after that, after activation of plasmin affect fibrin and fibrin degradation follows. So there are many factors which provide coagulation, clotting of blood. There are 13 factors in blood plasma, and there are many factors, clotting factors in blood cells, but blood is has a liquid shape. Why? It is because of rapid blood flow, smoothness of endothelium, same charge of formed elements and the wall of vessels, they are negative. Presence of anticoagulants on the surface of vessels, and presence of anticoagulants in vessels lumen. Must be balanced between coagulative mechanisms and anticoagulative mechanisms. And there are primary anticoagulants and secondary anticoagulants. The pre-existing primary anticoagulants are heparin, antithrombin 3, products of fibrin hydrolysis, dicumarin, belintan, inactive clotting factors in plasma. Secondary anticoagulants, they are formed as a result of blood coagulation. They are fibrin degradation products of thrombocytic thrombin. So it is a little about blood system physiology. If you have any question, ask me by email and by WhatsApp. Thank you for your attention.